Hey guys, it's John here. Welcome to the probability video. In this video, I'm going to show you all of the knowledge about probability that you need for the SAT, plus how to solve some more complex probability problems than you may be initially used to. If you want to know why, you can personally trust me. I've scored a 1550 on the SAT. I currently own the largest online SAT school community on this platform called Skool with over 23,000 members currently. And I'm trying to make the YouTube channel you're watching right now the best SAT YouTube channel on YouTube. Okay, as for this stuff here, it's worth mentioning that this is a video that a lot of people have been asking me to make. For whatever reason, people are just really struggling on these probability problems, so hopefully this video will actually help you. I'm going to be covering some more difficult probability problems in this video, so definitely should be good here. What probability really refers to, it's kind of obvious. You probably did this in like 5th grade. Basically, it's like if you have a group of marbles or something like that, and let's say that 4 of the marbles are red, so 1, 2, 3, 4, and then let's say 3 of the marbles are blue, like 1, 2, 3. This would be the process that you would need to use to figure out what is your chance of drawing a blue marble from the back. Now, you can probably just easily tell it would be 3 out of 7. There are 7 marbles in total here, and 3 of them are blue, so therefore the probability is that. Here's an actual rule that you can use for this. The formula you could say for probability is the desired thing divided by the total thing. In this example up here, the total amount of marbles in the thing is 7, 1, 2, 3, 4, 5, 6, 7. But the desired amount would be just the blue one. So 1, 2, 3, that's how we get 3 divided by 7. It's worth mentioning as well that if you put this into desmos, you'll get back this decimal. And what this really is just another way of writing a percentage. I have a whole video about percentages on the channel as well, but just for a brief overview of that, what this basically is saying here is that there's like essentially a 42% chance of drawing a blue marble out of these. So if I did 42% divided by 7, we get pretty much 3. It's a little bit different from that because we have some other decimal points I didn't include in here, but that's basically what we're showing as well. So this is another way just of writing a percentage. But on the SAT, you're typically just going to see it like this format with a fraction, so you don't need to worry about that. Likewise, I should just mention for this that if you have something like a decimal place like this, you can click this button over here on Desmos to make it into a fraction. Okay, that was a pretty bad fraction, but if we had something like 0.3, yeah, you can see here 3 divided by 10, we can have here 33 out of 100. If we had something here like 0.4, the fraction would be 2 divided by 5. So just press this button if you ever get confused. This saves a lot of time on the test. But let me just say here, the big thing you need to know for solving a problem like this is the total amount. This is the thing that's going to be changing what the answer is. It's going to have more of an impact on the answer than really anything else for these probability problems. For example, you may have a situation like this, where you get given this chart and you have to figure out, let's just say you're trying to figure out the percent chance that you're an algebra 1 considering that you are female. So if we were to calculate something like that, first we would look at the total amount. The total here would be 150 because there are 150 people who are female in total on this thing. So 150 would be the denominator, and then the top part, the desired thing here, would be the ones in algebra 1, which is 35 here. So that's the overall process for this. One thing that they often say in these problems to know if something is a total is if they say this exact word given. So they might say something for this problem, what is the chance of them being in algebra 1 given that they are female? So given is a really important word and it always means total. So if you ever see that, just know total is probably what it's referring to. And I want to give a quick example as for how big of an impact this can even have. So like I have here Mission 1400 Plus, and don't worry, this is not an ad. I'm just using this as an example. I guess it kind of is an ad, you could argue, but that's fine. So I have this premium school community, Mission 1400 Plus. This is not the one in 20,000 members. This is one just for people who really want to improve their SAT score fast. Okay, what if you're trying to do a probability here of what is the chance of you being in this program given that you are a student taking the SAT? Well, we can write our fraction like normal. How many students are taking the SAT? What is the total amount here? Well, I looked it up. It's about like 2.1 million. So 2.1 million students every single year take the SAT. And then what would be the desired amount for this? Well, the amount of people in Mission 1400 Plus as of the time I'm recording this video is 142. It might be a little bit less or a little bit more when you watch this because it's fluctuating every single day, but 142 is about the amount right now. So 142 divided by 2.1 million. And so if we write that into Desmos, we get this proportion 71 divided by 1,050,000. That is your chance of being in Mission 1400 Plus considering that you're an SAT student, which is obviously pretty low because there are many SAT students. But what if we were to flip this around for a second? What if we instead said, what is your chance of taking the SAT considering that you are in Mission 1400 Plus? So we would then flip this entirely around. It would say something like, okay, there's 142 people in total in Mission 1400 Plus. That would be our new total amount. And how many of them are going to be taking the SAT soon? Well, probably pretty much all of them. There might be a few people there who are just admins, but let's just say 140. So 140 people are taking the SAT out of this 142 in total who are here in this community. That proportion would be 70 out of 71. Basically, every single person there is going to be taking the SAT. So you can see by changing the total amount, you completely change how this fraction looks. This is a very big number, whereas the other one was a very, very small number. I know this might seem a little bit pointless, but you'll see why I'm focusing so hard on this after you get into some practice problems. And speaking of which, one thing that might help you as you go through this is thinking about this in terms of rooms. Think like you have a box here, and this represents every single person who is in the overall population for this thing. So for example, with SAT students, this would be 2.1 million, and this box represents everyone who's taking the SAT. The people who are Mission 1400 plus would be represented by this dot up here. So out of all these people, this amount are the ones in Mission 1400 plus. Likewise, in the other example we showed, we could have here 142 students, the 142 who are in Mission 1400 plus. And if we're now trying to show how many of them are taking the SAT, we'd be putting dots all over the place. It'd be pretty much completely full of dots. There might be like a small place where there isn't, but yeah, pretty much the entire thing is gonna be full of dots. So very big difference. One here, we have a huge amount and very few. This one, we have a very small amount, but then almost all of them have been taken. Okay, I'm gonna solve a few SAT problems involving this now. The big thing you should know going into this is that the top thing that's going to be hurting you while solving these problems is the information. What I mean by this is that when you see a probability problem like this one or this one, they're saying a lot of stuff here. They're saying a lot of different words, a lot of text, a lot of ideas. It's almost like as dense as a reading passage question if you really think about it. Your job here is to take this information and convert it down into the key points that you actually need in order to solve this problem. And chances are there's only going to be like maybe 2 or 3 for the entire thing. I'll show some examples of this in a second, but this is what you're going to be struggling with if you currently are someone who is struggling with probability. I assume you're not really struggling with this basic idea of desired over total. What you're probably struggling with is the idea of keeping track of all the information written down in a problem. And the way to fix that is write it down before you solve it. Students want to just immediately jump in and start solving the problem right away. That's how you get confused, and that's how you get problems like this wrong when you really shouldn't have been. You'll notice it's going to become so much easier when I write out the information before we start solving it. And one more thing as well, just before we get into this, you are going to notice for these first like maybe 3 problems, maybe 4 or 5, that they will feel fairly simple. Like you may be watching this video, you may think, okay, I'm fine with this. This is easy. You know, I don't need to watch the rest of this video. Just keep in mind, problems like 6 through 10 do get significantly harder than these first few. So don't be fully sure that you're fine with probability until you watch all of these problems, because they will get much harder. You might be perfectly fine with everything, but many of you probably are not going to find the last few problems as easy as these first few. I'll just say going into it. So let's start with this one now. The table shows the results of a study on Skool's tutoring. So random sample 300 students. So they either attended tutoring sessions or did not. So 300 in total are the amount being shown here. And each student reported whether they passed a placement exam. Okay, so just kind of explaining what's going on here. What proportion of students who attended tutoring reported passing the exam? So to write out some of the information here, we're trying to say of all the students who did go to tutoring, let's say T for that, what are the chances they actually did pass? So P out of T. Now it's much easier to see what's actually going on for this problem. So what are the total amount of tutoring students? Well, there'd be 150 we can see there. And what are the chances they passed out of those 150? It would be 84. You should note here that it would not be this 135 number because that's the total amount both in the tutoring and in the non-tutoring. We're just looking for the tutoring here. We see here if we do that, we get 14 divided by 24, so therefore B would be the right answer. Okay, now that you know the concept, go ahead and pause this video, try to solve this next problem for yourself and see if you get it right after that. Okay. So giving some information as well here, they say a patient is selected at random from the patients who improved. So for the information here, the total amount would be the ones that actually did improve. And then they're saying what's the probability that the selected patient received the placebo? So basically P divided by I. Okay, pretty clear what's going on there. Information is pretty simple. So the total I there would basically be, let's see, 117. And then what's the percent that actually did the placebo? That would be 39 out of the 117. Okay, pretty good. Let me just write that into desmos. So we have here, yeah, this is going to be 1/3. So therefore A would be the answer here. This one is one where writing down the information is going to become even more important than it was before. So we have here a greenhouse with 7 shelves of succulents and 4 shelves of ferns. You really need to write down the information for these. I have so many students who tell me to get problems like these wrong just because they're not writing down the stuff beforehand. So let me go ahead and do that. So 7S we can say, and then 4F. And then saying here, each shelf of succulents has 12 plants in clay pots. So I can say 12, let's just say this for C. And then 8 plants in plastic ones. So 8 and then go to P. And then it says here, each shelf of ferns has 9 in clay. So 9 that. And then 6 in plastic. So 6 like that there. Now it's asking us, what is the probability of selecting a fern given, so we have that given word here for the first time, that the plant is in a clay pot. So what are all the amount that would be in a clay pot? Well, there's these over here and then these over there. So we have to actually do some multiplication here. So let's just say 7 multiplied by 12, because that's the first amount for here. And then we have to also add that to 4 multiplied by 9. So we have 120 in total who are in a clay pot. Now, it's asking the probability of selecting a fern given that they're in the clay pot. So of the ferns, that would just be the 4 times 9 number. So we can just say here, 4 times 9 divided by 120, and we get 0.3, which would be the same as 3 divided by 10. So A would be the right answer here. This one's also a little bit more confusing, but all you do for this is you make an equation. You'll see how I do that just in a second. So we have some stuff here for handedness, and then instruments. It says the distribution and all that stuff. If one of the students who is left-handed is chosen at random, the probability that the student plays guitar is 3 divided by 17. So it says one of the students who is left-handed is chosen at random. So basically the total amount here would be the lefties, and then saying the probability the student plays guitar. So basically G out of all the lefties. So we'd be saying here, all of these add together for L, and then for G, it would just be this 3. I'm not going to go ahead and write that just to keep it, save a little bit of time here, but that's what we do. So we can say here, 3 divided by 6 plus 3 plus 1 plus this last one here, which is just X. So I can say X1 for that. And then I can say this, which is an equal sign thing you can do, 3 divided by 17, because it just says here that that is the amount that must be the guitarist out of the lefties. We see here that X must be 7, so therefore the answer for this problem would just be 7. You should be able to pretty easily see what's going on here. This is the total amount of left-handed students. This is the amount that's playing the guitar, and it's saying that would be equal to 3 divided by 17. Okay, go ahead and pause the video again and try to solve this problem for your own and see if you get it right. Okay, so 180 residents, they say whether they own a car and whether they commute by train. So 96 of the residents own a car. Of the residents who own a car, the probability that they commute by train is 1/4. So basically it's saying 96 are the ones with a car, and then out of those, 1/4 are the train users. Okay, that's pretty good. And then of the residents who do not own a car, which I guess we could just say here 180 minus 96 would be 84. So 84, let's just say N for non-car users. And out of those, 3/7 commute by train. Okay, how many of the 180 residents commute by train? So the total here is pretty easy. It's just 180, and then we're putting on top of that all the ones who are using trains. So we can just go ahead and calculate this using the numbers they've given us. So of the 96, there are 1/4 who do that, and then of the 84, there are 3 divided by 7. Okay, so 24 and 36, so we could say 24 plus 36 divided here by 180. So the answer again be this 0.3 number, or 1/3. It says how many of them commute by train, so 1/3 of 180 would be equal to 60. That is the answer here. Go ahead and pause the video again, try to solve this. So we have 9 pallets of ceramic tile and 6 pallets of stone. So let me go ahead and write that again. And it says each pallet of ceramic has 14 glazed tiles and then 10 unglazed. And then each pallet of stone has 8 glazed and 16 unglazed. This is what the probability of selecting a stone tile given that the tile is glazed. So all the glazed ones will be these and then also that. So let me go ahead and write that again. So these are the amount of glaze. So 174 would be the total amount here. And then it says, what's the probability of selecting a stone tile? So that would just be this 6 times 8 number. So 6 times 8 there. That's going to give us this number, which would be equal to 8 divided by 29, which yes, would be an answer over here. We're now getting into some of the harder ones here. So we're going to have one here where we have a situation where there's both of something. Let me explain what that means. So we have 250 patrons of a library, and they're recording whether each patron borrows a printed book or whether they borrow an ebook. A total of 130 patrons had a printed book, 102 had an ebook, and 46 borrowed both. Okay, that's gonna be really important later on. So they're chosen at random from the patrons who borrowed a printed book or an ebook, but not both. Which choice gives a probability that the chosen person borrowed an ebook? So let me go ahead and write the proportion here. So we're saying here they're chosen out of the people who borrowed a printed book or an ebook, but not both. So it'd be P or it would be E. And saying here specifically, it is the probability that it's an ebook. So E would be the amount out of that. Okay, so pretty simple, pretty good stuff here. The way that you probably would think that we solve it is you just do 102 divided by 102 plus 130. But the both thing, like I said before, is really important here. So the way to think about this is that you kind of have this group of people who is an ebook user. But you gotta remember that some of those ebook users are also the printed book users, because they say both here. There's some that are both in both categories for this problem. So therefore, there's kind of like this overlap zone where like you can't really say for sure what's going on. And for this problem specifically, they want us to exclude those. They say not both specifically. So the overlap is not good for this problem. So the way to get rid of that overlap is we just subtract what that overlap would be from each thing. So instead of 102, we would do 102 minus 46. And then for this here, we would do 102 minus 46, and then also 130 minus 46 as well, which gives us 0.4, which, yeah, we can see there is 2 divided by 5a. We're just removing this both people from the entire equation, both literally and figuratively. Okay, go ahead and pause the video, see if you can solve this one now. So we have a job interview thing. They say an applicant is chosen at random from those who had a referral or invited to interview, but not both. So let's just think what this total amount would be. So they have to be who had a referral or were invited to interview, but not both of them. So what that really is referring to, the referral ones, would be this, because it's not the ones that are invited and referral, just the ones who referral but not invited. So this one's like completely out of there. So just 48. And then it says here the ones that are invited, that'd be 98 extra in addition to the 48. We don't include this 170 number because that's the total for everything. So the total amount here we're basically saying is 48 plus 98. And this is what is the probability that the chosen applicant had a referral. So basically just 48 out of that. Answer to that there would be 24 divided by 7.3, which would be A. Okay, if you have made it this far in the video and you haven't been struggling at all, really good job so far. I will say these last two problems are honestly, in my opinion, very difficult probability problems. These are kinds of problems that you probably are going to see maybe at most one of on the SAT, but really likely not even that. This one may never show up because this is just a very hard, complex topic. But yeah, let's go ahead and give a shot at it regardless. So writing down the information is going to be really important here. We have N members of a club who took a certification exam. So I'm just going to go ahead and write the box again. I think boxes are going to be really helpful for a problem like this. So let's say this represents N. So it's all the people who even took, let's just say the EX or the exam. And this says 144 members used the official study guide before taking the exam. So I'll just go ahead and write in red here 144. So these are all the people out of the total amount of N who used a study guide. So it says of the members who used a study guide, 5/8 passed the exam. Let me write a new box here. So these are SG study guide enjoyers, and they, 5/8 of them did pass the exam. So I don't have to really break this up into pieces, but let's just say, 5/8 of these did end up passing the exam. So 5/8 did P. Then of the members who did pass, 3/7 used the study guide. So these are the passers, and then saying 3/7 used it. Okay, good stuff so far. And this, of the members who did not use the study guide, 2/9 passed the exam. So yeah, we have no study guide here. 2/9 of them did end up passing the exam. So yeah, we have all of these boxes now, and now we need to figure out how to actually do work on this problem to solve it. So what I would honestly suggest here is just try to figure out what you can do based off the numbers that are given to you. Now that's kind of basic advice, but that's really all you can do when you put into a situation like this with a really complex probability problem. But here's how I go about solving. So first of all, we have here 144 people use the study guide before taking the exam, and of them who used it, 5/8 passed the exam. So we can basically just do here 144 times 5/8 would be equal to 90. So these are the amount of people who used the study guide and as a result passed the exam. Now we also have this number here of the members who passed the exam, 3/7 used the study guide. So just kind of think about what's happening here. This first one is kind of like we were going forward. We have the amount of people who used the study guide for 144, and then we're taking that number to figure out the amount who passed, which would be this 5/8 times 144, 90 number. That's the amount. We're going forward here. This here is basically like we're going backwards. We're getting told here of the members who passed the exam. So like the first thing, 3/7 used the study guide. So first we have study guide, and now we're going to the people who passed. So we could think of it kind of like we have an arrow. So going from study guide to passing, and this time we were starting with passing, and now we're going to study guide. So kind of like the backwards thing there, you should hopefully be able to see. So because it's backwards, just think about what would make sense to do. We multiplied here. Instead, what we could do is divide. So we can take this number 90, because that's the amount of people who use the study guide and pass the exam, and we can do 90 divided by 3 divided by 7. Now, this may be the first time you're ever seeing this rule, but just know this works. If you ever need to go backwards, you can do this exact thing, divide, and that's going to give it. This number 210, think about what that would be. That's all the people who passed the exam. because this 90 number here would be referring to 3/7 of the total people. So the total amount would be this 210 number. Hopefully that makes sense. If it doesn't, just understand that this is a rule that you can use. Okay, so 210, and so that's the amount of people who pass. So if we do 210 minus 90, what that's really saying here is that 120 people did not use the study guide, but still passed the exam. So it's like, for example, if you think about it in terms of the SAT, it's like if you did not watch any of my videos, but you still get a 1500 on the SAT. That's the kind of idea we're going for here. And then we get this information here of the members who did not use a study guide, 2/9 passed the exam. So, think again, we're kind of going backwards again of the members who did not use the study guide, the amount who passed. So we can take this 120 number and divide it by 2/9. And this number here would be the total amount of people who did not use the study guide. Okay. All that being said here, this not study guide thing would be 540 in total. And then the amount you did use the study guide, as we said over here, would basically just be, it'd just be 144. So it's asking here, what is the value of n, which is the total amount of people in the thing as a whole. So we can just say 144 plus 540 is equal to 684. Hopefully you can see here now why I was kind of saying these problems would get a little bit harder, because I imagine a lot of you, even if you got the first few right, struggled maybe a bit on this one when you saw it the first time, but now you understand the process a bit more. Try to go ahead and challenge yourself to figure out this problem now. It's going to use the exact same kind of logic with going forward and backward. Just give your best shot. Let me go ahead and write out the information while you do. Okay, so hopefully you gave it a shot on your own. Here's the information that I have written for this. So 480 students, of these students who play a sport, 5/6 also joined a club. So let's go ahead and just use a variable for sports here because we don't know the amount of people yet. So we can just say 5/6 multiplied by however many played a sport. This is referring to the amount of people in the club. Then saying of the students who joined a club, 2/3 play a sport. So think about what this is saying again, kind of using that same logic as before. We're going first forward, sport to club. Now we're going backwards, club to sport. So we can just say here, essentially it'd be this 5/6 multiplied by S number, and we divide that now by 2/3. That is the amount of people who are in the club in total. That's the total amount of club people. And then of the students who do not play a sport, 1/4 joined a club. So we could basically just say here, since we know the total amount is 480, we could say 480 minus S multiplied by 1/4. These amount of people as well joined a club. So that's all the information we have here. We have this number 1.25, or it wouldn't be exactly 1.25 because it's just a variable. But yeah, we have this number here, which would be representing the total amount of people in the club. So what we can literally just do is say 5/6 times S plus this other number, this 480 minus S multiplied together by 1/4, and say that must be equal to this 5/6 S divided by 2/3 number. Just to reiterate where I got all these from, this is referring to the amount of people who are sports and then also chose to play a club. This is the amount of people who are not in sports but chose to play a club. And that must equal, obviously, just the total amount of people in the club as a whole. So it says here S would be 180. So the 480 that plays a sport, the answer is going to be 180. Hopefully this was able to help you. If you need some more practice on this, I would definitely recommend joining Mission 1400 Plus. You can increase the amount of people who are in it and also taking the SAT by doing so, and you'll get the access to over 28,000 practice problems on the website Onico we use. Many of them really hard probability problems that will test your abilities. Plus, if you struggle in any one, you can just post in the community and I'll respond to literally every single thing people post. That's it for me. Hope this video actually was able to help you and help you figure out how to do probability problems. I will see you in the next one, and make sure to always stay Gucci.